Hello, welcome to GES Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 5 on Algebra, and today we shall be simplifying algebraic fractions. I am your facilitator, Nala Debuo. As we do all the time, we have to warm the brains. And we warm the brains with very interesting mathematics questions. So today's warm-up question is this. If all the 54 members in your classroom shook hands with each other, how many handshakes would have taken place? If your class members are not 54, just take the number in your class and work out a rule to arrive at this answer. I'm going to share with you my answer. I got 1,540 handshakes. How did I get that? You can try this method. 1 plus 2 plus 3 up to 54 minus 1. And that will give you the answer. I know what you can use, and you know it. So in today's lesson, we shall simplify algebraic expressions. And one keyword we'll be looking at is lowest common multiple, LCM. To simplify algebraic expressions, there are some few steps you can follow. 1. Factorize expressions in numerators and or denominators in their linear form. When you factorize them in linear factors, it becomes easy for you to use. Now cancel common factors in the numerator and denominator where possible. This will reduce your fraction. Add or subtract the fractions by finding their common multiple, which we normally refer to as the least common multiple, or LCM. I know you know how to find fractions of numbers. It's the same process here. We are going to take some examples and see how we apply these steps. Simplify the following. 1. 5 plus m all divided by 2m squared plus 7m minus 4, or minus 1 divided by 2m minus 1. Here you will see that the first numerator is a linear factor, but its denominator is not. So let's try and factorize that into linear factors. So when we take 2m squared plus 7m minus 4, you have already been taught how to do quadratic factorization. And so this is a quadratic expression. And when you factorize it, you will get 2m minus 1 times m plus 4. Now this tells us that the 2m minus 1 on the second term of the expression is a factor of 2m squared plus 7m minus 4. So our LCM will be 2m minus 1 times m plus 4. But you realize that if you had not factorized, you would not know that 2m minus 1 is a factor of 2m squared plus 7m minus 4. Now, using our LCM, we'll now have 5 plus m minus 1 times m plus 4 all over 2m minus 1 times m plus 4. And simplifying the numerator will give us 1 divided by 2m minus 1 times m plus 4. So we have simplified our expression into a single fraction, and that is a simplified form. Let's take yet another example. Example 2. You have to simplify 3a squared minus 8a minus 3 all over a squared minus 9 all times 4a plus 12 divided by 15a plus 5. So you see in this expression, almost all the terms in the numerators and the denominators can be factorized and expressed in linear form. We take the first one, 3a squared minus 8a minus 3. This one we factorize. We're going to have 3a plus 1 times a minus 3. I don't have to show you how to go about factorizing this, but this is what we did in one of our previous lessons. And if I take a squared minus 9, it is factorized as a minus 3 times a plus 3. This you have learned again from the concept of difference of two squares. And of course, 4a plus 12 is factorized as 4 times a plus 3. And 15a plus 5 is 5 times 3a plus 1. Now that all my terms have been factorized, I just put them back into the expression. So I'll now have 3a plus 1 times a minus 3 all over a minus 3 times a plus 3. All this times 4 times a plus 3 all over 5 times 3a plus 1. Here you can see that some of the terms can cancel out. Cancelling a minus 3 and a minus 3 from the numerators and the denominator, I can also cancel a plus 3 and a plus 3. Equally, 3a plus 1 can cancel 3a plus 1 on the denominator. Isn't that easy? And when that cancellation is done, I'll have my final solution as 4 over 5. Very, very nice, isn't it? Let's take another example. Example 3. 12 plus x minus x squared all over 15x squared plus 14x minus 3 divided by 5x minus 20 all over 10x minus 2. So in this one, we again take these terms one by one and see if we can factorize them into linear factors. Our 12 plus x minus x squared now becomes 4 minus x times x plus 3. And again, 15x squared plus 14x minus 3 is x plus 3 times 5x minus 1. 5x minus 20 is factorized as 5 times x minus 20. And this, we can rewrite it as negative 5 times 4 minus x. And you soon see why. And finally, 10x minus 2 is written as 2 times 5x minus 1 when you factorize it. Now, putting all this back again into our expression to give us 4 minus x times x plus 3, all divided by x plus 3 times 5x minus 1. All this divided by negative 5 times 4 minus x all over 2 times 5x minus 1. We know that division can be written as an inverse of multiplication. And so, I'll rewrite the whole expression, changing the division to multiplication as 4 minus x times x plus 3 divided by x plus 3 times 5x minus 1. Now times, because I'm taking the inverse, 2 times 5x minus 1 all divided by negative 5 times 4 minus x. Now we've learned that all we have to do is to change the denominator and the numerators when you are dividing. Of course, what we are doing is taking inverse. So the inverse of the division is the multiplication. Cancelling out, we now have 4 minus x, cancelling 4 minus x. And this is why, if we had left it at x minus 4, the cancellation wouldn't have been possible. But because we made the 5 negative, it now becomes 4 minus x. And x plus 3 will cancel x plus 3. And finally, 5x minus 1 cancels out 5x minus 1. So our final answer is negative 2 divided by 5. Isn't that simple? Now, as usual, you have to do some tasks. And this you have to do at home, with your friends, in your school, wherever. So, simplify the following. 1. 5 divided by r squared minus 25, or minus 1 over r plus 5. 2. Negative 30 plus 11v minus v squared, all over 15 plus 2v minus v squared, all times 6v plus 18 all over v squared minus 36. And finally, 7 divided by x squared minus 5x plus 6, or plus 5 divided by x squared minus 3x. Until we meet in our next lesson, I've realized that we have explored the concept of simplifying algebraic fractions in this lesson. And I'll see you again in our next lesson. Thank you.